In this video, we are going to discuss the conjugates of a complex number, algebra of complex numbers, geometric properties of complex numbers, and the complex plane. In our previous video, we discussed the definition of complex number, examples of complex numbers, and how to compute when I is raised to the power of any integer. Before you continue with this video, make sure you go back to our channel and watch our previous video to enable you understand this video very well. Before we continue, I want to ask you a very simple question. Is 1 a complex number? Write your answer in the comment section. You are free to tell us why you think 1 is or is not a complex number. I will tell you the answer in the course of this lesson. We say that complex number is any number of the form z such that z is equal to x plus iy, where x and y is in R, the real number, and I squared is equal to minus 1, which implies that I is equal to the square root of minus 1. Conjugate of a complex number. The conjugate of a complex number z equal to x plus iy is a complex number z equal to x minus iy. What you will just do is change the sign to, if it is plus, change it to minus. If it is minus, you change it to plus. The conjugate of this complex number z equal to x plus iy is equal to x minus iy. The conjugate of x minus iy is equal to x plus iy. Example: find the conjugate of the following complex numbers. 1. Z equal to 2 plus 2i. The conjugate of 2 plus 2i is equal to 2 minus 2i. Is the same thing as I. We change this minus to plus. Then the conjugate of 1 plus 4i is the same thing as 1 minus 4i. Algebra of complex number. We have the sum and difference of two complex numbers. If z1 is equal to x1 plus or minus I y1, and z2 is equal to x2 plus or minus I y2. Therefore, z1 plus or minus z2 will be equal to, we add the real part first or subtract the real part, like x1 and x2. This is x1 plus or minus x2 plus or minus. We then add or subtract the imaginary part, this one with I and this y2 with I, which is y1 plus or minus y2. Example: if z1 is 1 plus this and c2 is this, c3 is I, z4 is this, find I, z1 plus z3, z2 minus z1, z2 plus z4. z1 plus z3 is equal to 1 minus 3i plus I, then which is equal to 1 minus 3i plus I is minus 2i. z2 minus z1 is equal to, we take the value of z2, which is 2 plus I, minus into bracket this thing, z1 is 1 minus 3i, then 2 plus I, we expand this, minus times 1, which is minus 1, minus times minus 3i is plus 3i. We now add, we now subtract the real part, which is 2 minus 1, we have 1, and I plus 3i, we have 4i. For z2 plus z4, we have 2 plus I, which is this one, plus 2x plus iy. We add the real part, 2 plus 2x. You know 2 and 2x are unlike terms. You cannot add them. You can now combine it. 2 plus 2x. Then we add the imaginary part, I plus iy. This is I. This is plus into I plus iy. We can factorize this thing out. We can factorize I out. We have 2 plus 2x plus I into 1 plus y. Now I want you to solve number 4. z1 minus 4z will be equal to what? In the comment section. The product of two complex numbers z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2. z1 times z2 is equal to x1 plus iy1 times x2 plus iy2, which is equal to, we multiply x1 by x2, we have x1 x2. Imaginary part by imaginary, we have real, which we multiply I times I is minus 1. This place will change to minus, and we multiply y1 by y2. We have y1 y2. We have plus, we multiply x1 by iy2. We have I x1 y2. Multiplying iy1 by x2, we have I x2 y1. We can now combine the real and combine the imaginary, which we have x1 x2 minus y1 y2 plus, can write this as, we factorize, we have I and we have I, we factorize I, Then we have x1 y2 plus x2 y1. I want to continue with this example. Find I, y, z1, z2, ii, z3, z4. z1, z2 is equal to 1 minus 3i times 2 plus I. Then we now multiply 1 by 2, which we have 2, and we multiply minus 3i by I. We have, you know that I times I is minus 1. Then that minus times minus is plus. This is plus 3. We multiply 1 by I. We have what? Plus I. Then 3i times 2 is minus 6i, which is equal to 2 plus 3 is 5, minus I minus 6i is minus 5i. I want you to solve this. Solve number 2. z3, z4 will be equal to what? If your answer is minus y plus 2ix, then you are correct. Before we continue, let me answer the question I asked earlier at the beginning of this video. Is 1 a complex number? The answer is yes. We say that a complex number is any number of the form z equal to x plus iy. Then 1 can be written as 1 plus what? 0i. We cannot, this 0 is a number. Then times I, we have 1. Now we have complex numbers comprises of natural numbers, real numbers, integers. This number we have the real and the imaginary. I hope that answer the question. The quotient of two complex numbers z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2 is z1 divided by z2, which is equal to this one divided by this times the conjugate of the denominator. The conjugate of this the denominator will be x2 minus iy2. x2 minus iy2. We now divide it by the conjugate of the denominator, which is x2 minus iy2. You know this one, the numerator can cancel the denominator, but we are going to multiply the numerator by the numerator and multiply the denominator by the denominator. And we multiply x by x, which we have x1 x2 I y1 times minus iy2. We have plus y1 y2. Then x1 times iy2 is minus I x1 y2. iy1 times x2 is plus I x2 y1 divided by multiplying this complex number by its conjugate. It simply means you multiply this first one and this first one and multiply the second one by the second term, which we have x2 squared minus into I y2 all squared. This is equal to x1 x2 plus y1 y2 minus I into x1 y2. This will be minus x2 y1, so that when we open this bracket we have this, and multiply minus I by this one, we have this one back, divided by x2 squared. Of course this will change to plus y2 all squared. We continue with this example. Find z1 over z2 divided by z2 will be equal to 1 minus 3I divided by 2 plus I times the conjugate of this denominator, which is 2 minus I divided by 2 minus I. This will be equal to 1 times 2, 2 minus 3I times minus I. This minus will cancel the minus. We have plus, then I times I minus 1. This will be minus 3. We go with this one. 1 times minus I minus 3I times 2. You have minus 6I divided by the conjugate of this, which we have 2 squared minus into I squared. This will be equal to 2 minus 3 minus 1 minus I minus 6I minus 7I divided by 2 squared is 4, then I squared is minus 1 times minus, which we have plus 1, and this will be equal to minus I minus 7I divided by 5, or minus into 1 plus 7I divided by 5. Express 1 plus I times 2 plus I divided by 3 minus I as a general complex form. This is equal to multiplying 1 times 2 2. Then I times I is what? Minus 1. 1 times I plus I times 2, we have plus 2I divided by 3 minus I, which is the same thing as this is 1 plus 3I divided by 3 minus I. And we have the quotient. We are going to divide 1 plus 3I divided by 3 minus I. We have 1 plus 3I divided by 3 minus I times the conjugate of the denominator, which is 3 plus I divided by 3 plus I, which is equal to 3 minus 3 has gone, then I plus 9I is 10I divided by, we have 9. I squared is minus 1 times minus is plus 1, which is equal to 10I divided by 10. 10 will cancel 10. This will be equal to I. That is the final answer. If you are enjoying this video, please do well to like this video and also subscribe to our channel. Drop your comments and share so that YouTube will recommend this video to more people. Welcome to MathKub community. Graphical representation of complex number. The graph of a complex number z equal to x plus iy, known as adjacent diagram, is a graphical location of the point z equal to x plus iy in a Cartesian plane, the x and y plane. In a normal Cartesian plane, we have the x and the y axis, but in complex plane we have the x, y and the z axis. If we take the distance from here to here, and we take the distance from here to here, we know that this will be your y and this is your x. At this point, this will become your theta, and we have r. Where theta define the arcmean of z. That takes us to magnitude of a complex number. The distance or magnitude of a complex number is the modulus of z, which is equal to r, this r, which is also equal to the square root of z times the conjugate of z. And we established in this class that multiplying a complex number by its conjugate give you a real number. Of course, you know that conjugate, multiplying any number by its conjugate, you have something like this: the square root of x squared. You take the first term and square it, plus you square the last term, which is y squared. polar form of a complex number. Consider the Argand diagram. This diagram. We know from trigonometry that cos theta is adjacent over the hypotenuse, which we have cos theta to be equal to x over r, and we are looking for x. X will be equal to what? R cos theta. And we also established that we have that sine theta is equal to opposite. Opposite is this y-axis. Opposite, which is y over hypotenuse, y over r. And we are looking for r. We are looking for y. Then y will be equal to r sine theta. In general form of complex number, which we have the z equal to x plus I y. Substituting the value of x, which we have r cos theta, and the value of y, which we have I sin theta, we have that this will be equal to z will be equal to r cos theta plus I r sin theta, which is equal to, we take r, we factorize r, we have r into cos theta plus I sin theta. This is the polar form of a complex number. Any complex number can be expressed in its polar form, and this is the general form of polar form of a complex number. Let z be equal to 1 plus I. The question now is, express z in its polar form. I want to represent this complex number in a Cartesian plane. The x and y axis, which we have x-axis we have 1, and the y-axis, the coefficient of I is 1. We have r. Value of r from Pythagoras theorem, r squared will be equal to 1 squared plus I squared, 1 squared, which is r will be equal to the square root of 1 squared plus 1 squared, which is equal to the square root of 2. And now r is equal to the square root of 2. To express in its polar form, we must find the value of r and theta. In this case, the value of tan theta is equal to tan opposite over adjacent, which is equal to y over x. We have that theta will be equal to the tan inverse of y over x. In this case, y is 1 and x is 1. From the question, y is 1 and x is 1. Theta will be equal to tan inverse of 1 over 1, which is equal to the tan inverse of 1. Theta is equal to tan inverse of 1 is 45 degrees. To represent in polar form, r into cos theta plus I sin theta. In this case, we have r to be equal to the square root of 2. Square root of 2. We have cos theta is what? 45 degree. 45 degree plus I sin 45 degree. Thanks for watching. Please, if you have any question or suggestion, let us know in the comment section. Watch this video again if there is any point you do not understand. Bye for now.